Hey guys, welcome back to KMath. Last video we discussed how to find these types of problems using the theorems that we talked about. Now we're going to use those same theorems to find the measurements of these given circles, applying those theorems to actually find these missing sides of multi-circle problems. So the theorems, remember, to recap, was the chord product theorem, secant product theorem, secant chord product theorem. So using those three, we can use them to solve for these two problems right here. These are a little more difficult, so you might have to keep up with the video and slow down and pause the video whenever you feel like you're behind. So let's get straight into it. So for number 7, what we have to do here is that we have to find the length AC, and it looks like we're missing two sides here. So we're missing this side right here and missing this side right here. Actually, let me draw that with different colors just to make it a bit easier to notice. So I'm missing those two sides right there, so we had to find them in order to find AC. Although it may not seem like we need to find I, but when you look at it, look at this problem, you are gonna have to find this chord's measure in order to find this chord's measure, because you're using the chord product theorem, so you just need to have to do that. So let's look for I first, because notice that it's inside an inner circle and every single measurement in the inner circle is already found, so we can use the chord product theorem to actually find I. So that's going to be 2 times 7, 14, is equal to 5 times I. So simply go that like that, and I should equal to 14 over 5. Then we have that. Now we can go into solving for this bigger chord. So we're going to look for AE. So we have, so we already have this measurement, so it's going to be 4 plus 14 over 5 times 10 equal to let's just do this one side first. So yeah, so 8.5 times, let's label this x as well, 2 plus x. And boom, we have our equation written right here. So let's just quickly solve this out. So we add it out. So 10 2, that should be 28 equal to 17 plus 8.5x. Add these like terms up. So 68 minus 17. 17 is going to be 51 is equal to 8.5x. So x is going to be equal to 6 here. Next, after we find x, now we have to really look for is actually what AC is equal to. So we have to add this up. So 6 plus 2 plus 7 plus 1.5. That's going to come up to around 16.5. Okay, for BD, what is it looking for? It's looking for this segment over here. We already found this measurement that was unknown, so we could simply just add those up, and we would add those up, including this 14 over 5, and we would get 16.8. So let's go on to the next one. So this time the circles are not in each other, but they are separate circles. It's separate circles. So we're gonna have to be a little more careful with our line segments and what we're actually using to solve the problem. but we're still using this chord product theorem, because you have these two chords that are intersecting in both circles, so we can use them to find a circle. But what are we looking for? Let's make sure we know what we're looking for. We're looking for this angle right here. Let's mark that with the red line. So we're looking for PY, and we're gonna have to find this right here, PR, and we'll have to find VY. So we can start either with the bigger circle or the smaller circle, it doesn't matter. I'm going to start the bigger circle and using this chord product theorem. It's going to be 5 times 3.6. I'll make this x, make this y. So 3.6 plus x is equal to 5 times 28. Okay, so then add this out. 5 times 3.6 is going to be 18 plus 5x equal to 5 times 28, so 140. I also just realized this, but you can divide 5 from both parties, so we're actually going to do that instead. But I was showing you that you can also just multiply this out. You can do either way. This is a little simpler if you just get rid of the 5, so it's going to be 3.6 plus x equals to 28 minus 3.6 minus 3.6, and you get 28 minus 3.6, which is 24.4. So you found PR. Now we're going to find VY. We're going to be using the same, so let's use some empty space right here. So we're using the same theorem to find VY. That's going to be 3.6 times 5 plus y is equal to 3 times 5 plus, oh shit, 15. So it's going to be 45 equals to same thing, 3.6 plus 5, 8.6 plus 3.6y. Oh wait guys, I messed up the measurement. So sorry. I added instead of multiplied, so it's 18. 18 plus 3.6y. So then get rid of this from the side. So that's gonna be 45 minus 18, 27. So y is equal to 7.5. So now we have all of these unknown angles, so we can just add them up now. So 24.4 plus 3.6 plus 5 plus 7.5, that's gonna add up to a nice 40.5. That's your final answer. If you guys came from the answer key, actually the teacher wrote it, miscalculated one of the small problems, so this is actually the right answer. So in case you guys just want to know that. Anyway guys, thank you for watching the video. If you guys didn't understand this topic, make sure to watch the last video so you guys can see what I'm talking about mainly in this video. But otherwise from that, make sure to smash the like button, hit the subscribe button, leave your advice in the comments down below, and we'll see you guys in the next video. Peace out.